in the Water Olympics at-home project, and we should be trying to rest a paperclip on the surface of this glass of water. So this happens as a result of cohesion. Cohesion is the attraction of one water molecule to another water molecule because of hydrogen bonding. They are attracted to each other. Now, this causes surface tension. And surface tension is because since the water molecules on the surface of the water are attracted to the water molecules below the surface of that water, they are attracted to each other, and then it causes surface tension, allowing small objects such as paper clips in this case, and or like water skippers or water bugs to reside on the surface of water. It gives it an unusually high surface tension. So I have my stopwatch here. I'm going to try and rest one of these paper clips on them. Ooh. In 22 seconds and 22.56 seconds, you can see this paperclip is residing on the top of this glass of water as a result of surface tension. Hello, this is the second event in the Water Olympics at-home project. So in this, I'll have to try and transfer the water from this cup over here on my left to this cup over here on my right by pouring it down this piece of twine. Now this is possible through cohesion and adhesion, which results in a capillary action. A capillary action is when liquids flow through like a narrow space, such as like blood vessels or the roots of a plant, while ignoring the external forces of gravity. Now this is possible because adhesion sticks the water to the vein, but the piece of twine right here. The adhesion sticks it to the piece of twine, but also the cohesion keeps the water together as well, and so it flows through together as one whole. So I'm going to start my stopwatch and try to get this as fast as I can. And go. And time with 23.78 seconds. And that is the second trial for our at-home project. For the third and final trial of the Water Olympics, we are going to be dropping drops of water onto a penny and see how many drops we can get before they fall off the penny. So we have 1 drop, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, and 18 is where it stops. Now, I believe that this is both adhesion and cohesion. Because adhesion is the phenomenon of where water sticks to another surface. Now obviously we have that as this water is stuck to the surface of the penny and is attracted to it and stuck to it. But at the same time, the water is also being dropped upon itself, and it's a little more difficult to see, but if you look at it from a direct angle, there is a bit of a dome of that water, and that would be a result of cohesion. So I believe that it is indeed both, because the cohesion keeps more water stuck together, but the water molecules on the bottom of this layer of water are also resulting in adhesion because it is stuck to the bottom of the penny. Now for the actual final event, my prediction for the balloon experiment will be that the balloon that's filled up with about 1/4 of water will take longer to pop than the other balloon, because water has a lot of small oddities about it. One being that it has very high surface tension, Also that it's denser as a liquid than it is as a solid, which is why like ice will float on the top of water. But one of those things is that it has a very high specific heat. Specific heat is the amount of heat it takes to raise the temperature by 1 Celsius of 1 gram of the substance. In water, it takes a decent amount of heat. So I believe that the balloon that's just filled with air will definitely pop boiling with water, because water absorbs heat very well, and it will take much longer for that actual balloon to heat up with the water inside.